Next, we will look into common source and common source amplifiers with source degeneration. The only difference between the common emitter and the common source amplifier is that instead of using a BJT, we are using a MOSFET, as shown here in this circuit. Since we have used a MOSFET, it has the three terminals: drain, source, and gate, and the source is grounded or common, so we call it the common source amplifier. Also, the resistance names change because it's a drain, so we call it RD, and everything else in the circuit remains the same. Let's try to draw the small signal model for this circuit. Remember, the MOSFET's small signal model looks like this, where I have drain, source, and gate. So at the input between the gate and the source there is infinite impedance, and at the output between the drain and the source there is a voltage controlled current source equal to Gm times the voltage between the gate and the source, that is VGS over here. So if we now substitute that into the common source amplifier circuit, then we have Vs going into the gate, source, Gm, VGS, goes to ground. We have RD, and this node also goes to ground, as this is the common source, so the source should be grounded. So we can easily calculate the output voltage VO, which should be given by minus Gm VGS times RD. VGS is basically equal to Vs because Rin is infinity, so there is no voltage division at the input, unlike the BJT. At input unlike BJT. So we can calculate the AV0, which is VO over VI or VGS, is basically minus Gm RD. We can calculate Rin is infinity, and Rout, which should be V out by I out. And note that I out is defined as the current that is coming out of the amplifier, and IC is the current this way, so I out is minus IC, and V out is the voltage across RD. So V out is basically I out times RD. So V out by I out is simply RD. So these three equations define the common source amplifier. As shown over here, you can see AV0 is minus GMRD, Rin is infinity, and RO is RD. So when you compare this with the common emitter amplifier on the left, the gain is kind of similar, GMRC and GMRD. The input impedance is the key differentiator, which is instead of R pi, which was a relatively lower impedance, the input impedance of the MOSFET gives the common source amplifier's input impedance to be infinity, and the output resistance is again similar, defined by the output bias resistance RC or RD. Next, we move into the common source amplifier with source degeneration. The only new thing in this circuit is we add a RE at the source of the common source amplifier. Let us draw a small signal model for this. Again, we have the V source going to ground, R source going to the gate. Between the gate and the source, we have an infinite resistance. Between the drain and the source, we have voltage controlled current source, GMVGS, and the output we have RD to ground, and this node is the source. Now interestingly, this time there is a resistance over here which is called RS, R source, and the voltage is VGS. Now let us try to calculate the voltage gain for this circuit. So I can write V0 as the current flowing through it, that is minus GM VGS times RD. Now note, in this case, VGS, which is the voltage across this, is not just equal to the gate voltage with respect to ground, but it also depends on the dependent current GMVGS flowing through the source, creating a voltage at the source. Let's call it VSRC. So let us try to calculate that part first. So we can write the voltage at the source, VSRC, is equal to the current flowing through is multiplied by RS. Now VGS, which is the voltage between the gate and source, can be written as VG minus VSRC times GMRS. So from there I can find V source multiplied by 1 plus GMRS is equal to GMRS times VG. Or I can write V source by VG is GMRS by 1 plus GMRS. So this is an important relationship where if I apply a gate voltage VG, how the voltage at the source will change due to the resistance RS in the common source amplifier with source degeneration. Now let us try to substitute this information in the output voltage. So the term we want to know is VGS, and from this equation we can write this is equal to minus GMRD multiplied by V source by GMRS, and from this equation we can then substitute, that is equal to minus GMRD times VG by 1 plus GMRS. Hence we can write AV0 or the intrinsic voltage gain as V0 over VG which is equal to the Vs is equal to minus GMRD over 1 plus GMRS. So we can see that the common sources gain, which was minus GMRD, is degenerated by a term 1 plus GMRS in the common source with source degeneration. If we try to find Rin, of course there is no current because of the open at the gate, so Rin is still infinity, and Rout is still equal to Rd is V out by I out. So let's try to compare the common emitter and common source both with emitter or source degeneration. We know the formula for the common emitter as we have calculated before. The gain was reduced, the input impedance was increased. So in case of common source, R pi tends to infinity, which means the input impedance will be infinity, and we can utilize this information to modify the common emitter formula to get the common source formula as well. The Rho still stays at Rd. We can divide the common emitter's voltage gain formula by R pi on the numerator as well as the denominator, which gives me 1 over 1 plus beta plus 1 by R pi. Now, assuming that beta is much greater than 1, we have, now assuming beta is much greater than 1, this becomes beta by R pi into Rs, and we know that Gm R pi is equal to beta, so substituting that, this term becomes Gm Rs, and hence we can write the formula as AV0. This is the exact same formula that we have found by doing the small signal analysis in the previous slide. Okay, so to summarize, we have learned that amplifiers can be characterized in terms of their open circuit voltage gain, that's AV0, input resistance Rin, and output resistance Ro. The common emitter amplifier has high negative gain and moderate input and output impedance. The common emitter amplifier has high negative gain, moderate input impedance, this is because of R pi, and moderate output resistance. If we do emitter degeneration, that lowers the intrinsic voltage gain but increases the Rin. Now, in case of common source amplifier, it still has a moderate negative gain, but it has a high input impedance because Rin tends to infinity, whereas moderate output resistance.